Good morning, good afternoon, good evening. Whatever the case may be, we are back and better than ever, graphing real polynomials part 2. Let's finish this up. Let's get to it, shall we? For general polynomials, and we get to use our graphing calculator here, find exactly the zeros, and it says exactly, so we have to be careful of this polynomial. So let's go ahead, crank out our calculator here, and we're going to enter in 3x cubed minus 14x squared. Make sure you get back down out of the exponent, plus 5x plus 2. Let's see what's going to happen here. So we got some zeros going on, and hopefully we're going to be able to find one where we're going to be able to get a real zero, or a nice zero, I should say. We certainly have 3 real zeros. Okay, that doesn't look very nice. Negative 0.2360, blah, 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 blah. So let's try for this one. Menu, analyze graph, 0, click to the left, drag to the right. That looks promising. Hopefully you recognize that as 0, 6 repeated, and we are going to trust that that is the fraction 2/3. But just for kicks, let's find the other one, see if it yields anything promising, and it does not. Here, so we know that if 2/3 is a 0, 3x minus 2 must be a factor. So I then know that 3x cubed minus 14x squared plus 5x plus 2 is equal to 3x minus 2 times I know that first term, 3x minus 2, times x squared plus ax minus 1. I know it's x squared because 3x times x squared is 3x cubed. Not sure what the coefficient of the x is, so I listed as a, and I know that a negative 1 times a negative 2 gives me the positive 2. So if I take this times this, I distribute it. Not going to bore you with the algebra, because you know we're going to, in this case, we're going to have to equate coefficients. So 3x cubed plus 3a minus 2 times x squared plus negative 3 minus 2ax, and then plus 2. And again, if I distributed this, gathered my terms that are squares and x's and my constant, this is what I would end up with. And then equating coefficients, 3a minus 2 is going to be equal to negative 14. And that's going to give me a equal to negative 4. And I'm going to have minus 2 or negative 3. I don't know why I have a 2 there. I think I said 3. Negative 3 minus 2a is going to be equal to 5. And that gives me negative 2a equals 8, which we already know that a is negative 4, so that's a check. So either way, you can get the a. And we finally get that p of x is equal to 3x minus 2 times x squared minus 4x minus 1. And so the zeros are x equals 2/3. Again, I am not going to bore you with the algebra. Using the quadratic formula, we get 2 plus or minus the square root of 5. And those are our 3 roots for the cubic. And our last example, find exactly the roots of this polynomial. It's a cubic. using some technology, we're going to find one of the roots. Okay, so finding exactly the roots of 6x cubed plus 13x squared plus 20x plus 3. First thing we're going to do is graph it. If I hit tab and go up, then I can just go through and delete this thing. So I have 6x cubed plus 13x squared plus 20x plus 3, and we graph it. And we have one there, and we hope that it's a nice 0. Otherwise, we're going to have to find some other ones, or maybe we have an imaginary ones that we have no more x-intercepts. We shall see. But we have negative 1.66667, which I hope you recognize as negative 1, 6. If not, you could mess around and figure out it's going to be negative 1, 6. But if you have a repeating decimal, you know that it's going to turn into a fraction. All right, so let's go back here. We know that we have one root of negative 1, 6, which means that we have a factor of 6x plus 1. So here we go again. We have, let's see, 6x plus 1 times x squared plus ax plus 3, okay, because a linear times a quadratic is going to give me a cubic. Again, the same reasons for the coefficients. 1 here, ax, because I don't know a, and then plus 3, because 3 times 1 gives me this constant 3. If I expand and equate coefficients, I'm not going to write out that equation. I will tell you that I get 1 plus 6a is equal to 13. Solving, I get a equal to 2. Also, you can do another check. A plus 18 would be equal to 20. And again, that's just like I did before, where I expanded out and then equated coefficients. I'm just not showing you this step here because I know you know how to do it. And so here I get a equals 2 again, so we can use that as a check. So now I get 6x plus 1 times x squared plus 2x plus 3. And so my roots, and again, I'm not finding the polynomial, I'm finding the roots, so that's why I don't have a p of x here. I think I put p of x on the other one, it really doesn't matter. So my roots are x equals negative 1, 6, and using the quadratic formula, which I won't show you, I get some complex roots, which are negative 1 plus or minus I root 2. All right, so not so terrible, and I hope you enjoyed it. I know I did, and with that, I am out.